Hi everyone, I'm Alice from House ZK, joined here with Sylve from Hyli. Very happy to have you back again.
Happy to be
with
here.
House ZK, Sylve.
Yeah, always a joy to be here.
Nice. And I know, Sylve, that Hyli recently announced its testnet release.
Mm-hmm.
So wanted to hear some more details about, first of all, how that's going, what results you've seen, any kinds of learnings that the team has taken away, and then also just for the audience, if there's any developers, any users who want to get involved, how they can interact with testnet.
Absolutely. So thanks a lot for mentioning it. We've been hard at work working on this testnet for 9 to 10 months. And we basically decided to do the hardest possible thing for a blockchain network, which is to build absolutely everything from scratch. So the vision that we have for Hyli is that we want to build the best blockchain for proof-powered applications. Whatever the proof system they use, whether it's server-side, client-side, we are extremely bullish about ZK technology, what it can enable. And the question that we want to answer is, how do you design a network so that you don't need to cram proofs into it, but rather design the blockchain network around proofs? That's really what we built. So 10 months of very intense work. We're a small team, but it showed different things. First of all, you can just ship things. We have a decentralized testnet, 8 nodes. We crossed 100,000 transactions and 50,000 proofs today.
Wow. Nice, congratulations.
Yeah, it's going really well. Really happy about this. We support the three major proof systems. So more obviously what Noircon today, SP1, RISC Zero. We built an entire testnet experience. We have a faucet, which is Fruit Ninja. You can play on mobile. You slice oranges, and each slice is a proof.
Well, that's fun.
Oh yeah,
Very
it's
nice.
not fun for the RISC Zero people and the SP1 people because they just get flooded. But it's really good fun.
Nice. And really great to hear that you're also really focused on improving kind of the developer experience and offering that flexibility for, say, developers to choose between these different proof systems. And really honing in on that user experience as well. Just wanted to hear some more of your thoughts on just the developer experience in general. Any kinds of kind of the like priorities that you're considering when it comes to the developer experience, any gaps that you currently see, or any challenges that you see currently in the space with how other projects are dealing with the developer experience that you're trying to really hone in on for testnet?
Part of the reason we wanted to build this testnet and we built it the way we did, which is an entire experience. We've got 5 different applications. We built a wallet to Explorer is because we wanted to be the first users of the network. You sometimes tend to see testnet which are, oh, it's great, it's live. We build it and they will come. Rarely works in action. So we have this vision of how applications should be built. Apps on Hyli are basically rollups. And not rollups in the sense that you need to do the OP stack. These can just be Rust servers that are approved with a ZKVM and you're off to the races. So it was really a great experience for us to really push this to the limit. And so there were some papers that were recently released by, for example, the Succinct team about verifiable applications, which is great because it's helping people frame better what we're doing. We read this paper and we were really thrilled because, every single thing we've been doing on Hyli aims to serve verifiable applications. So think of them as it's like ZK rollups, but you don't need to use a blockchain. You can just be a server. So a lot of the work that we will be doing over the next month is we built a lot of things, and now we need to really productize them, containerize them, make sure that the repos are well documented. But we really wanted to have something that works, and we could point hackers and partners to and say, okay, this works. Like we've actually built it. We'll look at the code and then we'll go extract the essence of it and build SDKs, etc.
Oh, nice. And in terms of, say, like, for example, these types of verifiable applications that can be built or any types of use cases that, say, are currently being built on the testnet, are there any that you're particularly, optimistic, excited about?
There's this whole zeitgeist currently about order books and provable order books. And it's a really good use case because if you've been around about blockchain, the main design that we've come up with are called automatic market makers or AMMs, such as Uniswap. And the reason we need to have this model is because we're very limited in terms of the computing power that you can have on the blockchain. So it works quite well. But it would be just really cool if you could build like Binance or a normal order book without all the quirks of automatic market makers or EMMs. And that's really where verifiable applications can really shine. And so what I'm really interested here is, first of all, ease of use. Most of the applications that we've built on the testnet, we've vibe coded a lot of it, and not necessarily only on the front end. And that's also because you can just use Rust, and these models are well trained to use Rust, so you can just give them a bit of context, and you're off to the races. The end goal for this is definitely something like Lovable, but for verifiable applications. And it's going to be much easier to do this than with Solidity. So the end goal here is that there's a flippening that's going to happen in the next years, which is we're going to build more verifiable applications that we have deployed smart contracts. And this will happen just because it's easier. In terms of very, very concrete use cases, the one thing that I really want to develop more on Hyli is what we've internally dubbed high TPS privacy. Usually privacy networks can be very, very difficult to build. So if you look, for example, like a comparison would be, you have Bitcoin, it was great, it was one coin, and then it was Ethereum, and we say, hey, how about we have multiple coins? For privacy coins, we have, let's say, Zcash. It works really well, but there's a single coin. And we haven't really been able to get to the point where we could have like multiple coins. So there've been like experiments. Aztec is working really well there, but I think we really have a compelling use case where you really can use client-side proving or Noir for the specific parts of your applications that can make sense. And maybe that's like 5% of it. And 95 uses SP1 or a 0, and you can benefit from like GPU proving, and it just goes much, much, much faster. So I like to think of it as, it's like Coke Zero. Like you get to have the taste and then none of the sugar.
Yeah, that's a great analogy. And just on that kind of topic for client-side proving and also like server-side proving. So, giving like, for example, we see a lot of different projects open these proof marketplaces, and people can delegate proofs to be generated within an open marketplace. But perhaps that may not be as well suited for any privacy-based applications where everything should be, kept locally. So I just wanted to hear some of your thoughts on just general developments with client-side proving, and maybe some specific scenarios in which server-side proving would be more preferable, like what you mentioned about, say, using RISC Zero or SP1 versus, say, like client-side proving application where maybe privacy needs to be considered.
We're very, very bullish about the long-term implications and the total addressable market of client-side application. It is absolutely, absolutely massive. But when you look at really where most of the investments has been going and where most of the improvements have been shown, it's in server-side proving, because there was a very, very clear use case in making sure that these rollups could go faster. And now we get to the point that ZKVMs work. To me, it's still bonkers. Like every time I use any of our apps, like, damn, it works. It just really works. And the ROS code, you just slap inside the ZKVM, you send it to succinct or boundless, and it just works, and it's insane. So we're one of the bets that we made at Hyli is that client-side proving was going to be a thing, and that server-side proving was going to keep on improving. And on the second case, we're definitely right on mark. It works. It's improving, and it's constantly improving, and that's really, really cool. So for client side, the thing is, I think the incentives are a little different. It's not something that you can productize very easily. The unit economics don't work the same. You cannot build a client side proven network. It doesn't work the same. So to your question about like when would you need to have client side versus server side, there's a great team, for example, using Noir. They build in ZK passports. It allows you to generate zero knowledge proofs that you're from a certain country, that you're over 18, etc., that your first name starts with an S, for example, all from your device. And the reason you need it on your device is that I'm not going to send my passport to an open source and a public proven network. This is not going to happen. So some of these use cases require privacy. So that's where you need client-side proving. Lucky for us, there are also some alternatives. The TateSeo team, for example, experiments with multi-party computation for proving. So you have like different nodes and they all split the work and none of them can see the whole picture, but it gets a proof. It's really, really promising. I'm really excited about this. I think Firma is also doing this. But the one thing I would really like to see is more TEE proving. So TEEs are like very private servers or hardened servers. People don't quite like them because it's very, I would say it's a very ham-fisted solution. So, oh yeah, just put it inside an SGX and call it a day. But I think it actually works. It gets you like 90% out there. So just like a ZKVM, put it inside a TEE. You have to trust Intel, but I mean, that's okay in my mind. And that allows you to generate proofs very easily, very fast, and in a privacy preserving manner. So I'm very excited to see. I think everyone agrees that client-side proving is the long-term goal, but we have these intermediate steps that we can have that gets us like 90% there already. So I'm very excited to see more of this.
Yeah, I am as well. And really great that you mentioned that kind of those intermediate steps need to be taken before we can reach towards that end goal. And we've been seeing this a lot, even on the side of like real-time proving. Right now, there's quite a lot of ZKVM teams who are trying to get towards like proving within that 12-second.
There was a talk at Berlin yesterday, which was 25 ZKVMs. Is this too much? And while the talk was happening, ZISC was also announced.
Yes.
The one from Jordi, who's run out of polygons. It's like, because now it's 26
ZKVMs, right? But at the same time, it is really great to see that so much innovation is happening. People are playing around with different types of architectures, different types of proof systems to see which one is, most viable. And just curious to hear about your thoughts relating to this as well. Once we, reach to real-time proving where the proving time and latency associated with it is not too much of like a technical barrier now. Are there any types of new use cases or applications that you can see emerging from that?
The one thing that's going to happen with this is, so Hyli, for example, we're a layer 1. And to be quite frank, like, we get a lot of shit for this because like, oh, why are you not an Ethereum layer 2? Why are you not like pledging your eternal soul to Ethereum, blah, blah, blah. The reason we were in the layer 1 is because in 6 months, none of this will matter. Because if you can prove Ethereum blocks in real time, we can have permissionless two-way bridges between any network to Ethereum instantly. And when that happens, you just get access to the entire Ethereum ecosystem and all its L2s. And so I think the line between what is an L1, what is an L2 is definitely going to blur. And it really is going to be a question of assets. You want to tap into assets that were natively issued on Ethereum, and that's great. And we obviously want to have this. So I think we're really going to see less of maybe like the philosophical question of are you layer 2 or not, but rather, okay, it's better to be a layer 1 because you have much more flexibility to what you want to do. We're not EVM compatible. We don't even have an execution environment. So we're much more flexible to do what we want to do. But having this ability to directly tap into the entire Ethereum ecosystem is just fantastic because, I mean, we're very happy if people keep on using them, but we're also very happy to enable new use cases that are more suited for proof-powered applications, provable exchanges, anything with ZK Passport, etc. So these are first-class citizens on Hyli. So I'm very excited to help liquidity on board on Hyli through this. I think that's going to be a very big enabler for a lot of innovation also at the protocol level.
Mm-hmm. Yeah, absolutely. And I know that Hyli also really focuses on, interoperability within your guys' own layer 1. So I wanted to hear some more of those implications just on the user side, user experience, especially when it comes to, having those native assets.
So we've had blockchain for like 15 years, and it's always been the exact same problem, which is you have a bunch of computers and all of them need to work together. And you can only go as fast as the slowest one. So it's like running a 100-meter dash with kids. So you would very much like to have only sprinters, but if you only have sprinters, it means that all your nodes are sprinters. And myself, I'm not a sprinter. I cannot participate in the network. So usually when you start thinking about like scaling blockchains, your friends who are a little like tech savvy, they're like, oh, why don't you just use bigger computers? Because if you use bigger computers, you only have bigger computers. But it would be really cool, and it's a great intuition. You want to use the bigger computers to do all the hard work. And it would be cool if the hard work could be verified on the smaller computers. And that's why we have proofs. That's what proofs allow you to do. But while doing it, what we ended up having on the Ethereum ecosystem is a lot of fragmentation. It's I think it was a talk by Tomasz recently from the Ethereum Foundation who went on Uniswap and just clicked on the drop down for ETH assets. It was like, there's 25 of them, all on different networks. I work at Ethereum. I don't even know which one this is. And it's very, very complicated. So, I think like L2s have pushed everything forward in terms of ZK, in terms of adoption as well. Like for me, I started using DeFi on Polygon POS, which is a sidechain. So, well, definition, blah, blah, blah. But you get my point. So the problem that we're now into is you get like all these little shards that are not really talking with each other. So there's a lot of discussion at the Ethereum level about base rollups. And it basically revolves around, okay, all of you, some of you are optimistic, some of you are ZK. Everyone sends their transaction on a shared data. That's what data availability is, so that we can all see what's happening on the other layers. We've included this natively on Hyli. Basically, we just said we don't need to wait for anything else. Hyli does two things. We do data availability, so like global sequencing of everything, and proof verification. So it's very, very easy. So every single app on Hyli currently on the testnet runs as a based ZK rollup. So you have like the faucet that is on its own little rollup, that can talk with like the wallet rollup at the same time. So in our mind, this should be table stakes, and this shouldn't take 5 years to implement. This should be normal and expected.
Yeah, absolutely. And as you mentioned, fragmentation has been a huge problem for a lot of LLMs, especially like Ethereum. So really great that there's teams like Hyli who are really trying to like go down and address the core root of the problem and building this all comprehensive stack, because you also have the verification aspect as well. So I think that's really great. And I do remember you mentioned previously, like in terms of just some excited, like things that you're excited about with including, say, proving within TE models. I'm very curious to also hear if there are any other sorts of like cryptographic tools or primitives, like in addition to ZK, or possibly that could be paired with ZK that you find have a lot of potential in.
The thing with ZK is that compared to the rest of the programmable cryptography toolkit, it's still nascent. We still have bugs every other week on ZKVMs, and they bug us to update everything because these are soundness bugs and they're horrible. But it's much more advanced than what you get, for example, with homomorphic encryption, FHE, and this is like the next level. And you have much more abstract things such as IO, like indistinguishable obfuscation. This is like the holy grail of everything. But it's very, very, very early. What gets me very interested about ZK, it's a great linchpin for blockchains. Like it's just great to build and help build blockchains and applications that run on the blockchain. And everything on top can be added. Like I really love MPC proving, because if you have proofs, then you can compute proofs in MPC. So it's like you start to have all these different Lego blocks that start interacting together. And I'm very, very excited for this overall. But I think right now, you always have this thing where like you try to climb Mount Everest, so you kind of see the top, and then you see also what's the next turn. And for us right now, it makes a lot more sense to really make sure that we can build the best network for proofs, because like future proofing everything, and then we'll see to add more programmable cryptography to it.
Yeah, really like that kind of comparison you made to just building first that base and then adding those Lego bricks on top of it later on. So right now we're still in those kinds of early stages, but as you say, ZK is kind of that linchpin for these blockchains that we should be focusing on. Okay, got it. And just in terms of what's coming next for Hyli. Now that testnet has been launched, curious to hear what's next on the roadmap, how any users, developers in the audience can get more involved.
Yeah. So we're happy with the testnet. People are using it, and it really is a show of force. This thing works. Now everything that we'll be spending all our time making sure that we can onboard developers, partners, anyone who wants to work with proofs in the blockchain environment. Like, we'll take it all. So if you're interested in any of this, you can go to Hyli.org, reach out to us directly on Twitter, on Telegram, and we'd be very, very happy to help you there. So it's going to be a lot of work in SDKs, documentation, use cases, products, just making the entire developer experience just perfect, because we were able to build all of these experiences on the testnet because we built it. And now, so we have all the context. Now we need to make sure that we can distill this context to other people.
Nice. Making the developer experience like the first class.
Exactly.
Yes. Nice.
We're pretty happy. For example, we're having ZK Hack at the end of the week. And so we're building a little scaffold which gives Cursor and other AI-powered IDEs or all the context about Hyli. So it helps you can talk with it. Oh no, like this is how you should interoperate with this wallet. Or oh no, this is how it should work, or autocomplete. And that's great help for us.
Oh, nice. It's very exciting. And yeah, thank you so much, Sylve, for coming on and for chatting. Really excited to see where Hyli's off to the next couple of months. Sounds like a very busy time that you guys are in. Congratulations again on the
Thank you very much. And thank you very much for having me.
Thank you.